Question 6. We're given a diagram and the series of points with distances from O, and we're given that OL is 400, OR is 600, OS is 300, and ST, not OT, is 600. And also L and K, we're given that LKT lie on a straight line, and KT is 5 times of KL. And we're also given unit vectors, P, 100 meters in that direction, and unit K, unit vector is Q in that direction, representing 150 meters. The first part requires us to express vectors OK and vectors RK in terms of P and Q. And the second part asks if you extend it, you can see whether you can see R from S without being blocked by K. So the first thing we would do is to simplify the diagram. So we draw a nice diagram here, and we write the vectors by converting distances. We have OL is 400 meters, so it's obviously for P, because P is just 100 meters, and LR is 2P, because OR is 600 meters. OS is 2Q, because that's 300 meters, and Q is 150 meters, and ST is 4Q. An arrow here, and 4Q, because ST is 600 meters. And we're also given that LK to KT is 1 to 5. The first step, write down the position vectors L, R, S, and T. So that's quite simple. L is equal to 4P. R is equal to 6P. S is equal to 2Q. And T, 6Q. So the first part asks for the position vector of OK. And OK, we can represent this as horizontal K. You can use the formula for the subdivision of a line. So it's K divides LT into the ratio of 1 to 5. Then the position vector of K is 5 times TL plus 1T divided by 6, which is 5 plus 1. And if you work that out, you will get 1/3 into 10P plus 3Q. Okay, so that's the answer there. For the second part, we have to work out RK. So RK is equal to K minus R. So that would be this minus that. So that's a P. So that's 10 over 3 minus 18 over 3. That gives you a negative 8 over 3. So that would be minus 8 over 3P plus Q. So that's the answer for part 2. For part B, we first work out the vector RS, which is simply position X vector S minus position vector R, and that's 2Q minus 6P, which we can write as, we can factorize out 2 into minus 3P plus Q. Now, we notice that Rk and Rs are not parallel because if you look at the position vectors, we have a q here and a q here, but here we have a minus 8 over 3p, and here we have minus 3p. So we can conclude that these are not parallel. And because both of these vectors go through R, then therefore they are not collinear, meaning the 3 points R, K, and S are not in the same line. So we can say R, K, and S are not collinear, and therefore the conclusion is that R is visible from S, and that's because it's not blocked by K. So that's the answer for part B. So that concludes question 6. So this is an interesting question. So here we give you a challenge. The challenge is, if there is another point, so it's the same diagram as the one above. So if there's another point B, which lies right there, that actually blocks the line of sight between S and R, or R and S, what is the ratio that it divides LT? In other words, if B divides LT in a ratio of 1 to, let's say, lambda, 1 to lambda, then what is lambda? And similarly, if B divides SR in the ratio of 1 to mu, for example, 1 to mu, then what are the values of lambda and mu? So these are scalar numbers. So if you can work it out, please write your answers in the comments below. Thanks for watching.